Let's welcome Amrit Sanjeev again as he shares on how keeping your app small size or size small will help you to scale better opportunities in a market like India. Ladies and gentlemen, please welcome Amrit Sanjeev.
Thank you all. I am promising this is the last time you're seeing me on stage. Anyways, for the next half an hour, we're going to talk about some of the things that we need to do in order to keep the app size really small. It is very important that we do that. And some of these things you might be already doing, but I'm going to, as a sanity check, I'm going to cover most of the things that you should do. The thing you should actually notice about some of these decks are you can't really pick and choose. You really might have to do all of these things. They'll all add a little bit of space saving, and then the all inches will add to the mile. So you really need to kind of think of some of these things are already done, but if you're missing something, go and add that to your applications in the next release cycle. So quickly, these are things I'm going to cover: why we should focus on app size, how does it affect us, and some techniques. I'm not going to discuss something completely radical here. There might be things that you've already learned, but what I want you guys to understand is note down all of them so that you kind of figure out the one that you're missing and then apply back in your app to get that space saving. So getting some basics out of the whole idea. App size, when you talk about app size, there are four numbers that we look at. Raw APK size, then something called download size, then there is an install size, and then there's an update size. There are four numbers here. Now, the reason why I want to kind of clarify some of these things is because when you kind of talk and communicate to others in your team as well as to your management or to other developers outside in the community, you want to kind of specify which one you're actually talking about and which one you want to focus on. There are teams which actually focus on install size a lot. There are teams which actually focus on downloads, the raw APK size a lot. So it depends on what use case you guys are actually working on. Some of these things might become a little more important than the other, and you need to understand all these things. Just to look through them. Raw APK size, the file that you actually get after you compile and make an APK, build an APK on your disk, that's raw APK size. The reason an APK, by the way, is just a nice zip file. There are certain files, if you look to the compression levels of each of the file under APK, there are certain files which are like completely uncompressed, like resources ARC. They're uncompressed files. So not everything in an APK is compressed, but the whole file together, that zip file, or the zip file basically, is the raw APK size. So if you actually build using, say, Android Studio and create an output file, the APK file, that is a raw APK size. So if you look at that. Now the download size is what Play sends out. Play compresses this thing again so that over the wire, the data that somebody actually needs to get this app is actually minimal. This sometimes is very close to the APK, and some of them are kind of less. So these two numbers are slightly different from each other. The install size is basically the size that your app will take when somebody installed on their device. This would have things like the .ota files, which is the ahead-of-time compilation files. If you see, before N, L and M had that, and in N we have a JIT compiler now, so we don't have the OTA files as much as a problem. But if you look at the landscape or the ecosystem as such, you have devices on those platforms also. So the OTA files will actually add. The native libraries are uncompressed and kept. Again, they will add to some size increase. So that is the size that is there on the disk. Apart from the data that you actually have, download, like your caches, your database size, all these things will be there. That's the whole size that the app is actually consuming on the device. Now the update size. Now when you actually update an app on Play Store, that doesn't mean that the user will get the entire app again. So the way Play Store works is that it actually chunks out and sends a patch, which then gets, the patch which is much smaller. So if you have a 10 MB app and you updated a few things to it, released a 10.1 MB app, it doesn't mean that the user downloads 10.1 MB. He downloads maybe a patch of 2 MB. And then that gets patched on the device, and then that 10.1, 10 MB app becomes a 10.1 MB app. That's how Play actually updates the whole thing. So the update size is always, at most times, smaller than the entire app size. Now, every time you actually do an update, this is what the user sees. If the user goes to Play Console and then looks at how much he has to download, then they'll see the update size. If they actually have to install, they see the download size, not the APK size. You can look at tools like APK Analyzer to understand these numbers. Update size won't be there. Update size, you can use APK estimator, size estimator. There's another tool. It's an open source tool. You can take a look at that. And that will allow you to kind of understand how much is the difference if you really want to control that. Now, APK size out of the way, let's look at what's there in a APK as such. These are some of the constituents of an APK, or rather, these are the app code, resources, and miscellaneous stuff. If you look at app code, that's a classes.dex which contains all of your code. Then you have your native libraries. These are like if you are using third-party libraries which are specific for particular instruction set or architectures, there will be multiple .so files that you have to add. That will be part of the app code again, but that's separately kept. Then you have resources. All of your PNGs, your drawables, all those sort of things are there in the resource folder. Then you have resources.arc. The strings file, the identifiers, all these things are here. This again is uncompressed. One interesting thing that I heard when I was actually listening to the I/O this year was that some developers do compress this to make the APK size smaller, but that's a bad practice because if we have to read, anything has to be read about that app, even the app name, this file has to be uncompressed, which means there's a lot more work that the app or the device or the launcher is doing every single time that app is there. So there are certain things which are counterintuitive. It might sound like, oh, there's an uncompressed file there, let's compress it, make the APK much smaller, but it's best to leave it as an uncompressed file because that makes it more efficient to be used. Now, when we look at things under the miscellaneous, you have assets. You have assets. You have things like database files that you might want to, like the raw files that you might want to use. A lot of people actually put their pre-processed SQL files in there and then load it from assets. Some people put their fonts in there. So there are files like that which is kept in. Metainf basically has the certificates and keys that you would use, and manifest is a standard manifest file. So this is basically gives us a fair sense of what's there in an APK and what are those sizes like. So that is the basics part that we wanted to kind of clear off before we start into it. Why should we focus on APK? When we actually look at a cost of an app, we look at that number, and when we see that as zero, we think, does that mean that the cost is zero? Is that the actual cost? No. The real cost is, you have to consider the cost of downloading the app. If you're on 4G, or if you are on a paid network, and you have an 100 MB app to download, that 100 MB of downloading is the cost of the app. The regular updates that you send out is actually cost that somebody is incurring to get your app to the latest one. Again, also the data, also about running the app. So when you calculate the cost of your app, don't just look at the sticker price of it that you put on Play. You also need to look at the cost in terms of, like, if you want to estimate the real cost impact to the user, you want to estimate how much it is actually costing him from downloading and continuously using the app. And again, device storage is another pain point. 1/3 of users run out. This is 2017 stat. 1/3 of the users in NBU countries, next billion user countries, run out of space on a daily basis. And weekly, they remove the most heavy apps, the ones that actually use the most amount of disk space, straight off. So this is a real problem. This is not like a problem that was there in the past and we still have people talking about it. This is a real problem today also. A lot of people run out of space. And you might be thinking, oh, my app is just 15 MB. How is it going to just... But you are also contributing to that. You have to see that when you are not shown up as the app, when you see this old dialogue, this is an older version of Android, but when you see that thing and you click on it, the first thing it says is these are the apps that are taking most amount of space. But interestingly, in Android, When this dialog comes in, there's also a broadcast that you get. Apps can actually listen to that broadcast and then say, I will remove iCache. I will clear up all my image cache, unnecessary files that I've stored, which makes you a less likely candidate to be there in the top of that list. Less number of uninstalls because of that. So, housekeeping, please clear up your caches which you use just for the efficiency of your app when the device is running low on memory. And people do actually look at who's using most and then clear it. Maybe it is just that your app is small, but you have a lot of data. You don't use any LRU caches, or you don't use any time-based caches. It's like a permanent cache which just keeps growing. Finally, 2 months later, the user sees that, oh, he's downloaded 300 MB. And when you look at the data size, it'll be 300 MB, and he'll just decide to remove your app. So continuously clearing your caches, reacting to some things like these broadcasts are important. Now, ProGuard is something most of you guys might be using anyways. But I just want to call out because there are a few things in there which really needs fine-tuning. One, let me call out what ProGuard is. ProGuard is basically a Java optimizer. It basically changes the code without changing its, changes the variables and how you can read readability of the code without changing the functionality of it. And it also optimizes to be more compact. Now, a couple of things it does very well. One is dead code elimination. If you ask a flag minified to be enabled, what it does is it identifies the areas of your code which you are not using. It could be functions, it could be classes, which you are not using, and then removes them out before building the final app. Which means when you add a third-party library and you use only a part of the functionality of the third-party library, the part of the library that you're not using is not added to your classes.dex, because there's no path to reach to that, so there's no point doing that. So dead code elimination is something ProGuard does really, really well. It is enabled for release by default. So ProGuard will automatically runs. If you do it in debug, that's why your debug release and these releases, if you keep these flags off, you don't really need to do minified enabled for debug, basically because it slows down, because there's another process of finding the dead code and removing them and all that to happen. So you don't really use it for your debug releases, but you kind of use it for release and staging. The other interesting thing that it does is obfuscation of code, which basically makes the code kind of not readable. If you actually try to disassemble and see, decompile and see, you will see ABC. If you get a crash report for a ProGuarded app, you will get, without uploading the mapping files, you will see A as a class name, B as the function name, B1, B2, this sort of thing. So it shrinks all these large names into really small ones and makes it more unreadable. But it can also do something called resource shrinking. Resource shrinking, basically, when you say shrink resources, it applies the same code elimination logic down to resources that are there in your device, on your folder. So things that are not being reached, not being used, it will automatically remove. Now, I would personally don't prefer ProGuard to be the place where things get removed. The right way, in my opinion, would be to go use lint and realize what is unused, and then remove all those unused resources. If you right-click on your REST folder right now in Android Studio, you have an option to say remove unused resources. And then before it refactors, it will tell you this is the files that I'm going to remove. You can actually turn on lint in, and this is one thing that some of the teams that I work with have done before is, if for certain lint rules like unused files, lint actually finds those unused files. It's a warning right now. If you're skipping it, that's because it's a warning. You turn that to a fatal error, which initially will become, like if you have not done it before and you have a lot of unused files, and it becomes a big surprise that, oh, the app will not compile unless I remove, like, say, 20 resources out of it. But it's important that you remove it, and nobody intentionally adds resources that they don't use. Over a period of time, you add, you remove, there are certain functionality which was deprecated in code, but you forgot to remove the assets for it. These things happen all around. So this is something that you want to kind of ensure that lint is something that you use to do this. Oh, there, right. Couple of things to think when you do lint. Lint does not go through assets file. So if you have bundled 5 fonts that you don't use anymore, lint is not going to tell you about that. Then it also, it's up to you to keep your assets file clean. So if you have multiple versions of your DB file, you forgot to remove it, lint is not going to save you at that point. So be careful about these small things. But having lint rule turned to fatal for a few of these sanity checks will help you keep the code clean over a period of time. Now, if you look at an APK, which basically bundles a native SDK, a native library, this is how it would look. You have your text file, strings, that's the first blue, that's needed. Then you have the architecture-specific native library code, yes. But if you look at most third-party libraries, what you would see is that they will provide for x86, ARM, MIPS, ARM versions 7, all these different architectures, they actually provide you libraries for it. But on a particular device, on a particular architecture, you're only going to use that architecture's SO file. So universal APK sometimes doesn't make a lot of sense if you really want to crunch your app down. And again, when you look at drawables, you have XHDPI, all those different densities. Now, in any device, there's only one density that you're going to use, which is the default density of that device, screen. So you're not going to change that. So at the end of it, when you look at an APK, it looks like this. All those green points can be eliminated, saved space, if you delete all of it or remove all of it somehow, and the app will be much smaller, and the functionality will remain same. No crashes, nothing will happen, because only the blue areas are used by your application on that device. This is the case of a universal APK. Now, there is something called as multi-dex, which multi-APK, not multi-dex, multi-APK, sorry, where you build different APKs for different densities, or you remove certain densities and you say that the certain densities are not used, which means that you can actually create APKs in such a way that if an MDPI device is asking for the thing, you only serve the MDPI APK. So you will have one for MDPI, you will have one for HDPI, XHDPI, and so forth. When a device which is basically with that density comes and asks for an APK, you serve the right one to them. That way, you remove all the other assets that you add unnecessarily to that. Very similarly, you also have a way to remove unsupported architecture. There are certain architectures like MIPS. In my opinion, there are not many devices that support it. So adding, and if you look at your analytics and kind of track what are architectures or your users are actually using, you will be able to find out the most common ones and then write an ABI filter like this, which will allow you to exclude anything which is not, the library might include all of them, including MIPS, and you can say that this is what I needed to add into my APK. This will still add that way. You can even split based on architecture, and that there will be multiple APKs that will generate it. So there's a downside to multi-APK approach, is that your testing effort as well as your maintenance effort increases with that. There is benefits. There's definite benefits to doing it, but you also have to understand the downsides that you're testing, because you're creating 5 APKs means you have to test all the 5 to ensure everything is working fine before you upload. To ensure every one of those versions are right, all these maintenance part of it, 5 of them have to be signed, all before you upload. All these things have to be done. So that is something that that is a downside to it. The new play signing that you've seen, where you upload the unsigned APK signed by a upload as signing key, that will allow a lot more optimization to be done before sharing it to the external when a user asks for it. So play will actually create and sign and send out your app, and that way it will actually be able to manage the splitting and all that automatically. Now come images. Image is something that we all use. Couple of standard things which most of you might have already know, but let me call them out. Using the right format of the images. Instead of using ARGB 888, try to use 565, which is half the RAM usage and half the disk space usage. So if you're loading a 2 MB file, the same thing in 888 means with ARGB is like it basically stores it with 2 MB, and if you're loading the same thing in 565, it'll load in 1 MB. 1 MB in terms of 1 MB of memory is all it requires for it, because the format is more, and visually there's not much of a difference in there. The loss of information is so little that visually you can't find the difference. Most of the apps that you see and use on your devices use 565. Glide by default uses 565. In Picasso, I think you have to set it to 565 to use that way. Anyway, optimizing your PNGs is one way. There's a lot of PNGs that you have in your assets folder or drawable folder. If you're using them, then crunching your PNGs is of easy, low-hanging fruit. If you've not done it, try doing it. You will get a lot of space reduction. There are tools which actually compress PNG and keep it, and create files which are like really small compared to the original file. And there's not much of, there is not any visual difference in the quality of it. So try to use that, compress them. The other one is using 9-pass images wherever possible. There are a lot of times where people have like full splash screens, where the splash screen is one icon in the center and a full border around it, which is one color. Things like that does take space. And if you look at it, most probably the splash page is actually the most expensive resource that is there on that app. Most expensive in terms of most space consuming in RAM. By using a 9-pass, you can actually reduce that size again. The WebP, wherever possible. WebP is another format which is actually 33%, roughly, something between 20 and 35% less, more of a compressed one. So if you have a 1 MB PNG, a WebP version of it would be somewhere between 750 and 90K, 75 and 90K. Sorry, 750, you get the point. It's less than by 30% roughly. So that is something that you want to use serving from your serving infrastructure. The reason is, this is not just on the device that you will actually save. Assume you have 1 million users, or assume your infrastructure on a day per user serves 10 MB of data as images, okay? Now, assume you have 10 million users a day. You are a very successful app, so you have that much users. But then you multiply 10 million, that's 100 million MB of data served from your server for that bandwidth you pay for it. Your business pays for it. Would you like to make that somewhere between 75 and 85 MB? Or 100 million MB, then you have like 85 million MB. So the saving actually becomes really multiplied as you see it from your server side. From a device side, it's just one image which is less, but still, from a server side, it saves a lot of time, cost. But WebP has one thing. If you're serving, it is actually supported for 4.1 onwards with transparency. So if you are actually supporting devices, if you're supporting versions much below that, then you need to kind of take a call whether you want to use it or not. And yeah, move on to the next one. Vector drawable is another one that you can actually use to kind of have a single asset for multiple densities. So things like icons in your screen, you should actually use an SVG, and you should have, there's backward compatibility from till 14, and gradient support is from 24 plus. So there is certain vector drawables won't solve all type of your images, but a majority of icons, those sort of stuff can be actually changed into this, and instead of having 5 densities, you can just put one density that scales across. It's scalable vector graphic, that's SVG. SVG. So it can scale automatically to different densities. So this, again, one thing to again remember when you do this is SVGs, when they are very large, they consume CPU and memory because they have to be expanded or rendered. So very large SVGs are not really recommended because they take larger amount of time and CPU to render. So you want to kind of ensure that the smaller ones are SVG. If you have really large ones, you have to test them and measure them, how it is performing on a low-end device, and see whether that's just not too much time taken. Fast translation. This is very interesting thing. If you look at support library, for example, how many of you guys add support library to your application? How many of you have used this option? Not many. So I'll tell you one easy trick. And how many of, I assume majority of you guys support not more than 5 languages in your app. Now, the support library is translated to 82 languages. localized. In all your apps, those 82 languages, all the strings are there for the things that you're using. You might use a android.ok, android.r.ok, or from the support library, something like that, a resource. All the 82 versions are added into your app now. By adding this one line, rest config, with the languages that you support, what you basically do is tell the system that, hey, my app supports these languages. Anything outside of these languages, I'm not really interested in keeping in my app, which means in this case, only 2 languages will be actually added, English and French, and everything else will be removed. In an app that I had, I tried this the first time when I came past this idea. It was an app of 9 MB. Most of the things I talked about has been done. Just by adding this one line, I saved 600 KB in my app. Straight off. Yeah, roughly 600 KB. Such a low-hanging fruit, one line of code. Has no impact on any of your code base. So this is something that you might want to go ahead and do it tonight if you're not done this. Because this will not only happen in the support library, this past translations will actually happen in every library that you add which have localization. You add a third-party library which has localization, you will again face the same thing. So by providing this in your default config, you will specify to the build system that, hey, I only need translations for these 2 languages, rest of them resource config, I can forget about it. So this is something definitely that you should try and do today, if not done already. Downloadable fonts, I did talk about it earlier today, but this is again an area where you can save a lot of time. Like I said, assets, most people have created custom experiences with fonts. Like the look and feel of the app changes when your font changes, right? So a lot of people have their custom fonts that they use in order to create a very differentiated look and feel. But at the same time, these font files have to be added into your assets, and then you use it. Every user downloads all of this. A lot of times earlier, I've seen when the Roboto was just launched, a lot of people added Roboto to their application. Even though that's the default on the device, they added Roboto, and everywhere they've used it. That's somewhere about, if you add like 5 or 6 fonts, that's going to take like about an MB or 2, depending on the font file, give or take, MB or 2. If you're using downloadable file, you're not adding any of that information. You're telling your program to say, go talk to the font provider, get me this font because I need to use it at this place. These are the places I'll need to use. So your app will actually go contact the font provider. Font provider will go connect to the font contract and get the file, use it. Sorry, the font provider will go connect to the font cache or to the original provider, external provider, get the font, put it in the cache, and the next time another app asks it, your user is not downloading it again. Assume this is a device that does not have Roboto in there. You've asked for Roboto, one app asked for Roboto, and it downloaded. Next time your app came down, the user is actually running your app. Your app requests for Roboto. It doesn't go to the font provider and download it again. It just goes to the cache, gets it immediately. Your APK size is saved. User's download cost is reduced. The memory footprint on the device is reduced. This is a total win-win situation. This is in support library today, version 26. You should use it. If you are updated to 26, you should go ahead and update your code to use this. Really, really useful thing. And it has the entire Google font catalog to start with, which has 800 fonts, around 800 fonts right now. Now, this is the last slide that I have, but this is again the AAPT2 tool. This basically has something called version collapsing. There are multiple versions, like when you have V7, V4, V13, things like that. There are versions in which the behavior changes, and or there are certain resources which are declared differently. And what happens is certain resources are no longer used, but because you're supporting a range of versions, this would be there in your files. The version collapsing will actually bring that all to one, remove all the unnecessary things. So this is something you don't need to do under the hood happens. And there's a smarter cruncher, there's a resource deduplication algorithm running on it. So this is something, again, really useful when you want to kind of reduce app size. Yeah, with that, I hope some of these things you guys are already doing, and you've learned a few things like the REST config, which you can actually go back and apply today. But this is always a constant battle. Reduction of app size is always a constant battle. And you always have to assess what you're giving in to do that, because this is a trade-off. You might have computation happening, increasing because you're doing these sort of really low-level optimizations. So you really always measure against what is actually the good practice, what is the trade-off that you're doing. So be aware of both of this. Thank you.